When the heart stops beating, does consciousness disappear instantly, or can it continue a little longer? Although circulation suddenly stops, billions of brain cells do not immediately become completely inactive. Scientists discovered that brain activity can continue briefly after the heart has already stopped beating. However, electrical signals alone cannot confirm whether conscious awareness still truly exists during those final seconds. Understanding consciousness requires more than measuring electrical activity, because awareness cannot be directly observed by instruments. The patient's brain activity is stabilizing.
Heart rhythm is returning to normal.
Vitals are holding, we have a chance. Without oxygen, neurons progressively lose communication, instead of shutting down all at exactly the same moment.
The signal from the frontal lobe is weakening.
What is the origin of these remaining bursts of
Are
activity?
these conscious thoughts?
Current scientific evidence cannot determine the precise moment conscious awareness permanently disappears after cardiac arrest. To answer this mystery, scientists turn toward remarkable cases involving survivors of near-death experiences worldwide. Some patients revived after cardiac arrest later described memories from moments they should have been unconscious. I saw my body from above, looking down on the doctors. Then the light came.
How did the light make you feel? Can you describe it more?
It wasn't a feeling. Researchers compared these memories with recorded brain activity to search for measurable scientific connections. In several cases, electrical brain activity appeared briefly after the heart had already stopped beating. Scientists believe oxygen deprivation changes normal brain function, although its exact effects remain incompletely understood today. Different research teams have reported similar observations, yet interpretations remain cautious because evidence is still limited. Large international studies continue collecting data to better understand consciousness during cardiac arrest and recovery. Current evidence remains intriguing, but it cannot prove consciousness survives after clinical death has already occurred. The biggest mystery may not be brain activity, but whether awareness depends entirely upon that activity. To explore that question, scientists next investigated exactly how consciousness emerges inside the healthy human brain. Understanding consciousness begins with understanding how billions of neurons communicate continuously inside the living human brain. Every thought, memory, and sensation depends upon countless electrical signals traveling across interconnected neural pathways every second. No single brain region creates consciousness, because awareness emerges through widespread communication across many different networks. When circulation suddenly stops, these complex communication networks gradually begin losing their coordinated electrical activity together. Without fresh oxygen, neurons progressively fail to exchange information efficiently throughout the brain's intricate communication system. Scientists believe consciousness may fade as these synchronized patterns slowly lose their organized electrical coordination over time. Exactly when awareness disappears remains controversial, because current experiments cannot directly measure conscious experience itself. Scientists can observe brain activity, yet awareness itself remains hidden behind every measurable biological process today. Every new discovery improves our understanding, but none has fully explained how consciousness truly exists or ends. The next challenge was determining whether near-death experiences reveal genuine awareness or extraordinary brain activity alone. Near-death experiences have been reported across cultures, religions, and medical systems throughout the modern scientific era. I remember a clarity of thought, a vividness that felt more real than reality itself, right there on the edge. The ECG is stabilizing. They're back.
We have a pulse. Good work, everyone.
Scientists carefully compared these reports against medical records to verify which details could be independently confirmed. One leading hypothesis suggests oxygen deprivation may temporarily alter perception during critical moments before brain function ceases. Another hypothesis proposes sudden bursts of coordinated neural activity might briefly influence conscious experience near death. The patient exhibits unique cortical activity.
It doesn't align with any known pathology.
We need to run more simulations of the neural network. Researchers continue collecting stronger evidence because extraordinary claims require equally extraordinary scientific proof before acceptance. Perhaps near-death experiences reveal unknown brain mechanisms rather than consciousness existing independently from the brain itself. To answer that possibility, scientists next examined how quickly the dying brain actually shuts down after oxygen disappears. The human brain consumes enormous amounts of oxygen, making it extremely sensitive to interrupted blood circulation. Within seconds, neurons begin struggling to maintain the electrical communication required for normal conscious awareness. Electrical patterns gradually lose coordination rather than disappearing everywhere inside the brain at exactly the same instant. Different brain regions may stop functioning at different times, depending upon their oxygen demands and resilience. Quickly restoring oxygen greatly increases the possibility that brain function and awareness may recover successfully.
The readings are stabilizing. Heartbeat and oxygen are strong.
We have successful neural activity. Recovery outcomes depend upon many factors, including oxygen deprivation, treatment speed, and each patient's medical condition. Scientists continue improving emergency medicine while searching for deeper answers about consciousness during critical medical emergencies. Some neural networks can recover surprisingly well when oxygen returns before irreversible cellular damage begins. These discoveries suggest the boundary between consciousness and unconsciousness may be more gradual than once believed. But the ultimate question still remains. Exactly when does conscious experience finally come to an irreversible end? After decades of research, no single explanation completely accounts for every reported tunnel of light experience. Current evidence suggests the retina, visual cortex, and brain chemistry may all contribute simultaneously during crisis. Conscious perception likely emerges from many interacting systems instead of one isolated biological mechanism acting alone. Scientists continue testing every hypothesis because extraordinary experiences deserve careful investigation. So global collaboration is steadily improving our understanding of consciousness, perception, and survival during critical medical emergencies today. History reminds us that many scientific mysteries required generations before convincing evidence finally emerged through research. Perhaps the tunnel of light reveals more about the living brain than about death itself today. Every new discovery brings science closer to understanding one of humanity's oldest unanswered questions about consciousness. Today, researchers cannot confirm whether tunnel experiences reflect perception, memory formation, or multiple biological processes together. If you experience the tunnel of light, what scientific explanation would seem most convincing to you?